if we think of the atom as like a house, we would come here, this would be the nucleus right here, and as we start to add electrons, alright, so we would start with one electron, and that goes on the first floor, so the first energy level in the s orbital. So we would take care of this one first. Alright, I'm going to put a check here. Then, let's say you have some more electron friends come over to your house. You need more room. So the 1s is already full, so you put the next group of friends in the 2s. So that one's full. If more people come over, if more electrons come, we start to fill the p orbitals. So we fill these up. Then if more friends come over, more electrons, then we go to the third level, the third energy level or the third floor. We start with the s, and then we go to the p. And notice how I fill up the p first, then I go to the d. And notice how I'm filling up each room with one before I come to a second electron. And then I would just keep going up to the fourth level, etc. Alright, so let's look at a couple things here. Now notice that how many electrons can fit into a room, so to speak, or into an orbital? The answer is 2. Okay? So how we represent that is we're going to represent that with arrows. And we represent, usually, it doesn't matter if you put an up arrow first or a down arrow, but we go up arrow, then a down arrow. Because of the different, what we kind of say are spins, they behave differently, so we always have to have an up arrow and then a down arrow. And how we abbreviate this now, if there's 2 electrons in the 1s orbital, we abbreviate it 1s2. That's what this picture means. Okay, now next there are some rules or principles to building an electron configuration, and I'll let you read those, but we will always follow these 3 rules as we build an electron configuration. This is the Aufbau principle, Pauli's exclusion principle, and Hund's rule. Now I'd like to show you what order the orbitals are filled and why it has this order. And it all has to do with energy again. So as we start to add electrons, we start in the 1s and we fill the 1s first. Then we go to the 2s, then the 2p, and we fill it up according to our rules. According to our rules. Then the 3s, then the 3p. Then here's where it gets a little tricky. So I'm going to put a little star here. Because notice we don't go from the 3p to the 3d. Why? Because look, the 4s is at a slightly lower energy level than the 3d. So it goes from 3p, then the 4s gets filled, then the 3d. So these energy levels are filled not just in some random order. It has to do with energy. So then we would go from 3d because of then the next one is, if we follow over to our energy, is 4p. So then we go to the 4p. So this is where it gets a little confusing, and I'll show you some ways to remember that here in a second. Now make sure you have your page with your handout with the periodic tables that I gave you. You have a couple periodic tables. And we start with this diagram here. This is a good way to remember it. This picture, like it says here, it says start here and move along the arrows one by one. So what this shows us is the 1s is first, then the 2s, then we go to here, the 2p and the 3s, then the 3p, the 4s, and we just keep following this chart. Now another way to do it is by simply looking at the periodic table. So we would start here with hydrogen. This is going to be the 1, and then we would fill the s. And over here, helium's the oddball one. Helium is a S, but it's the only one on this side of the periodic table. In fact, some periodic tables you see a helium drawn in right here just to make it easier for this type of electron configuration. So after we fill the 1s, then we follow our chart and it says to go to the 2s. So this would be the 2s. Alright, where do we go next? We jump over here. It's not the s. The s's are over here. If you see the pattern, the s's are here, except helium. The s's are here. Now let's see, we just did the 2s. I'm going to cross that off. Now we go to the 2p. So over here in green, these are the p's, and this would be the 2p. So we'd fill up the 2p. We go this one, 2, 3, 4, 5, 6 electrons in the 2p. Then, okay, I use that one. Then we go to the 3s. So here's our 3s, and we fill up this one and this one, 2. Then we go, let's our chart say, from the 3s, okay, we go to the 3p. So here's our 3p's, and we fill up these, 1, 2, 3, 4, 5, 6. Now here's where it gets a little tricky. From the 3p, we go to the 4s, alright, 4s. Then here's the trick. From 4s, cross that off, we go to the 3d. This is the 3d. So all this middle block here that's in yellow, these are the d's. And I guess the way to remember it is you just have to remember it's one off. You know, sometimes people draw a little line down here like this. You can go down so you remember that this is the 3. So then we just keep going. So from 3d, we would fill up the d's, we would fill up all these, and then we would hit the 4 s's. And let's see on our chart, 3d, or sorry, the 4 p's. Fill up the 4 p's. So from 3d to 4 p's, then we go to the 5 s's down here. 5 s's, we fill up these, and this would be what? This would be the 4 d right here, right? 4ds. I did 5 s's, and then I go to the 4d. So you can, either way to remember it is fine. A lot of people remember it with the periodic table, which is fine, and other people remember this chart or a combination of both. Either way is fine with me. Let's practice writing some orbital diagrams, and we'll start with nitrogen. So I look up nitrogen on the periodic table, and it has 7 electrons. So I come down here and I go 1, 2, 3, 4, 5, 6, 7. This is what my orbital diagram will look like. Now I'm going to write that in a special notation. So I write 1s. How many electrons are in the 1s? 2. It's not squared, it means 2. 2s has 2, and the 2p has 3. So this is how I write my electron configuration. And I say at 1s2, 2s2, 2p3. And we'll come back in a little bit and fill in this lower box in a kind of a shorthand notation for writing this. But let's try another one first. Next one I look up is neon. Alright, neon has 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I write it like this: 1s2, 2s2, 2p6. Titanium. I look up titanium. It has 22 electrons. So this one's going to be pretty big. So I fill it up, fill up the s's, go ahead and give it a try. And it should look like this. So when I write it, let's write it down here. 1s2, 2s2, 2p6, 3s2, 3p, how many? 6, 4s, 2, and 3, I'm out of room, 3d2. And if you count up these numbers, they should add up to the number of electrons. So 1, 2, 3, 4, add them all up. 6, 10, 12, 18, 20, 18, 19, 20, 21, 22. Silicon. Let's look up silicon on the periodic table. There it is. It has 14. So go ahead and build it. Should look like this. Let's write the electron configuration. 1s2, 2s2, 2p6, 3s2, 3p2. And again, always add up these numbers to make sure you get the right number of electrons. Let's try carbon. Find carbon on the periodic table and go ahead and build your electron configuration and write your electron configuration. Do your orbital diagram first, and it should look like this. Alright, so carbon would be 1s2, 2s2, 2p2. 1, 2, 3, 4, 5, 6. That's right. Let's try fluorine. 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice how I filled up the P. I fill up all the P's first, then I go back. So it's 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. Now I'd like to show you how to write a shorthand notation, because you could imagine as we get a lot of electrons piled up around our nucleus, some of the standard notation could get out of hand. So there's a shorter way to write it. So here are the rules. I'll let you get those. And let's go back to nitrogen. Nitrogen, let's find it on the periodic table. Alright, and according to my rules, I go back to my most recent noble gas. So if I go here, the last noble gas that is located on the periodic table right before the element. So in this case, that would be helium. So I come in my brackets, I write helium, and then I write everything after helium. So that would be this and this and this, this and this. So it would be 2s2, 2p3. So this is short. This is a shorthand version. We just basically eliminated the 1s2. So you say, well, all we eliminated was 1s2. But you could imagine when we get way down farther in the periodic table how it would save a lot of writing. Let's do another one. Let's do neon. Alright, now neon is a noble gas, so that we use helium again. So I'll put my bracket, helium, and what do I have? I have this row again, but I go a little farther here. Alright, so that would be 2s2, 2p6 this time. Next would be titanium. Now titanium is pretty big. This is a good example of why we use notation in the first place. Alright, so titanium is down here. Last noble gas is argon. So I write argon. And that would be 1, 2, 3, 4. I want to start in the 4 S's. So I can get rid of these and I can go 4s2, 3d2. Because remember, these are the D's. 3d2. Next, silicon. Silicon is here. Last noble gas is neon. And that would be 1, 2, 3s. So I need the 3 S's. 3s2, 3p2. 3s2, 3p1, 2, yes. Carbon. Helium again. And let's see, this is a 2s, so I need these. 2s2, 2p2. Fluorine. Fluorine is, where is fluorine? Here. Helium again. And we would be on the 2s, so I get rid of these. Let's cross that off. 2s2, 2p5. That's how you write shorthand notation.